Discussing in this module 3. ఓకే, 2 పార్ట్స్ గా మనం డివైడ్ చేసుకున్నాము. ఫస్ట్ పార్ట్ వచ్చేసి CI1 లో వస్తుంది, సెకండ్ పార్ట్ వచ్చేసి మనకి CI2 లోకి వెళ్ళిపోతుంది. సో ఇక్కడ మనము టు హ్యావ్ ద లెర్న్ ఫస్ట్ హాఫ్ is completely, and first 2.5 modules is completely in a CI1 purpose. Okay, the next purpose we have learned in the third unit of part, second part, and fourth module and fifth module. So this is the second CI2. Okay, so final exam is completely all the modules will be together, we can asking, but we have the in your common to internal choice exam is the further we have learned 2.5 modules, first 2.5 modules. Okay, in your module CI exams on maybe 6th onwards. Okay, sir, power
no sir, 8th
inverse. ఇట్స్ ఏంటి నాకేం అర్థం కాల క్వశ్చన్. 8th క్వశ్చన్
A/4 ఇన్వర్స్ కనుక్కోమంటే క్యాలీ హామిల్టన్ థియరం యూజ్ చేయాలా సార్?
అవును, A/4 and A ఇన్వర్స్ బై యూజింగ్ ఇంటూ క్యాలీ హామిల్టన్ థియరం.
ఒకవేళ మెన్షన్ చేయకపోతే సార్ క్యాలీ హామిల్టన్ థియరం అని
క్యాలీ హామిల్టన్ థియరం అంటే మనకి వి హావ్ గెటింగ్.
కాదు సార్, ఇప్పుడు క్యాలీ హామిల్టన్ థియరం
వాయిస్ బ్రేక్ అవుతుంది నాన్న.
క్యాలీ హామిల్టన్
థియరం means we have the given square matrix, its own characteristic equation is satisfied. Okay ma,
నేను ఏమంటున్నానంటే దాంట్లో మెన్షన్ చేయకపోతే కూడా అలానే చేయాలన్నా సార్ అని అడుగుతున్నా సార్ మీకు. అంటే ఐగన్ వాల్యూస్, ఐగన్ వెక్టర్స్ ఫైండ్ అవుట్ చేసి చేయాలనా అని.
హలో
సార్, ఇప్పుడు క్యాలీ హామిల్టన్ థియరం తోని చేయాలని దాంట్లో మెన్షన్ చేయకపోయినా క్యాలీ హామిల్టన్ తోనే చేయాలా సార్ A/4 A ఇన్వర్స్?
అలా ఎలా ఉంది నీకు, ఎక్కడ ఉంది అట్లా?
అంటే క్వశ్చన్ బ్యాంక్ లో ఒక క్వశ్చన్ వచ్చింది సార్, అందుకే అలా డౌట్ వచ్చి అడిగా.
ఏ క్వశ్చన్ నాన్న?
ఒక నిమిషం
ఆగు, నేను షేర్ చేస్తాను, నాకు చూద్దాం మీకు ఏ క్వశ్చన్. ఓకే, ఏ క్వశ్చన్ ఒకసారి చూద్దాం ఆగండి. ఏది నాన్న? ఇదే కదా. దీంట్లో ఏ క్వశ్చన్ నాన్న? క్వశ్చన్ నెంబర్ చెప్తారా?
మాడ్యూల్ 2 లోకి వెళ్ళండి సార్ ఒకసారి.
మాడ్యూల్ 2నా? ఓకే, మాడ్యూల్ 2
కొంచెం పైనకి వెళ్ళండి సార్. ఇంకా
క్వశ్చన్ నెంబర్ వెరిఫై క్యాలీ
సార్. ఆగండి సార్, కొంచెం మెల్లగా తీయండి సార్.
మెల్లైనా ఓకే. చూడండి మీకు ఎక్కడ క్వశ్చన్ ఉందో అది చెప్తే నేను ఇక్కడ కూడా క్యారెక్టరిస్టిక్ పాలినామియల్ ఈక్వేషన్ వెరిఫై చేయమన్నాడు 8th క్వశ్చన్లో. నెక్స్ట్
12th one సార్, 12th one అదే.
సాటిస్ఫై ఇట్స్ క్యారెక్టరిస్టిక్ ఈక్వేషన్ అన్నాడు కదా.
అంటే దీనికి క్యాలీ హామిల్టన్ థియరం యూజ్ చేయాలి కదా సార్ A ఇన్వర్స్ చేయడానికి.
వాట్ యు మీన్ దట్ సాటిస్ఫై ఇట్స్ క్యారెక్టరిస్టిక్ ఈక్వేషన్ అని చెప్పాడు అంటే దాని మీనింగ్ ఏంటి?
క్యాలీ హామిల్టన్ థియరమే సార్.
క్యాలీ హామిల్టన్ థియరమే కదా.
ఎస్ సార్.
మరి ఇంకా ప్రవీణ్ చెప్పనాను. ప్రవీణ్ హలో. ఇంతేనా డౌట్?
ఎస్ సార్, అంతే.
Yeah. In module 3 we have second part we can start it now. Okay, first part we have the learning here. Part 1 we have the discussing is module 3. In this we can write into module 3. Okay, in module 3 is a functional several variables mean value theorems. Okay, so in this we have the discussing first part వచ్చేసి నేను part A అని రాస్తున్నాను. part A, part B in this module. Okay, first part లో వచ్చేసి mean value theorems. Okay, and functional several variables. Okay, so in this we have the already you learn Rolle's theorem. Okay, Lagrange's mean value theorem. Okay, next Cauchy's mean value theorem. Okay, this first part will be completed in your module 3. Okay, in this the second part we have the discussing here part B. Here we have the discussing into the partial differentiation. Okay, and next one chain rule. Next total derivative. Okay, next one Euler's method. Okay, next one Jacobian. Next in this Jacobian we have to learn functional dependence and independence. Independent. Okay, so next the last topic is maxima and minima. Of two variables or more. Okay, then last in this you have the Lagrange multiplier. Okay, so if this is topic you have learned in this in the module. Okay, so in this module we have the mean value theorems. In the first three we have considered as a CI. exams, and CI1 and CI2 we can asking to the functional several variables in this partial differentiation. Partial differentiation లోనే మనకి పార్ట్స్ వచ్చేసి చైన్ రూల్, టోటల్ డెరివేటివ్, యూలర్స్ మెథడ్. ఇదంతా మనం ఆల్రెడీ నేర్చుకున్నాము, బట్ వీ హ్యావ్ స్మాల్ రీకాల్. ఓకే, చిన్న రీకాల్ చేసేసుకొని వెళ్ళిపోతాము. అంత డీప్గా ఏం వెళ్ళాము. ఫస్ట్ 3 టాపిక్స్ వచ్చేసి, ఫస్ట్ 3-4 టాపిక్స్ వచ్చేసి జాకోబియన్ ఈస్ వెరీ ఇంపార్టెంట్. What is the Jacobian and functional dependence? What and functional independent అంటే ఏంటి, ఎలా రాస్తాం అనేది మనం ఇంపార్టెంట్, అది నేర్చుకోవాల్సిందే. నెక్స్ట్ maxima and minima of 2 variables or 3 variables. Okay, here we have giving to the Lagrange's multiplier. Okay, this is a completely in your syllabus. ఓకే, మనం ఇక్కడ రాయగానే ఎన్ని టాపిక్స్ అని భయపడాల్సిన అవసరం లేదు. ఎస్, ఆల్రెడీ మీరు ఇక్కడ వరకు నేర్చుకున్నారు. యూలర్స్ మెథడ్ వరకు ఇన్ ఇంటర్మీడియట్ లెవెల్ ఆల్రెడీ వీ హ్యావ్ ద డిస్కసింగ్. So once we have the recalling, what is the partial derivative and what is the chain rule, what is the total derivative and what is the Euler's method. So this is we have once recalling and a few problems we are doing every problem. Okay, so if any doubts on this syllabus, ఇంకా ఏమైనా డౌట్స్ ఉన్నాయా, ఇక్కడ ఏమైనా మిస్ అయినాయా మీ సిలబస్ ఇచ్చిన ప్రకారం చెప్తారా చూసి? హలో, ఎనీబడి హ్యావ్ ద మిస్ దిస్ టాపిక్? ఏమైనా మిస్ అయిందా టాపిక్? ఎనీవన్? హలో 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 హలో
సార్,
ఇంకేమైనా డౌట్స్ ఉన్నాయా? ఈ సిలబస్ ఇంతేనా, మీకు ఇంకా ఏ ఎక్స్ట్రా ఏమైనా ఉందా, తగ్గించామా మీకు ఇచ్చిన సిలబస్ ప్రకారము? హలో మాట్లాడరేనానా? మీతోనే మాట్లాడుతుంది. మీతోనే నేను మాట్లాడేది. మాట్లాడండి. ఎస్, ఏనా క్వశ్చన్స్? ఓకే, మీకు అంతవరకే ఉంది. ఫంక్షనల్ సెవరల్ వేరియబుల్స్ అండ్ maximum minima ఆఫ్ functions of 2 variables and 3 variables, method of Lagrange multipliers. సో ఇన్ ఫంక్షనల్ సెవరల్ వేరియబుల్స్ అంటే ఏంటో నీకు తెలియకుండా నువ్వు డైరెక్ట్గా అందులోకి వెళ్ళలేవు కాబట్టి, ఓకే, యూ లెర్న్ ద కంప్లీట్ టాపిక్ partial differentiation. Okay, what is a differentiation? Anybody? Unmute yourselves and tell me. What is a partial differentiation? What is a differentiation? Any function or any equation? Okay. Hello. Hello. Ma చెప్పండి. What is a differentiation? What is a continuous function, ma? Hello.
It moves on, sir.
What is a continuous function? Kaushal. Hello. 138. Hello. Hello. 138. Vishnu. Hello. Hello. Are you audible, ma'am, my voice?
Sir.
What is a continuous function?
it moves on, sir, up to a certain limit.
It moves on the certain limit. Okay. Yeah, we have the discussing in that topic. What is a differential equations or what is the differentiations? Okay, if any function is independent and dependent variables, and here the dependent variables is derived with respect to one or more independent variables. Their derivative is called as the differentiation of the equations. If any equation to involve dependent and independent variables, their derivative with respect to one or more independent variables, that derivative of equations will be called as a differentiation of the equations. The differentiation are the two types. Okay, the differentiation are two types. The first one is ordinary differentiation, and second one is the uh, partial differentiation. Okay, in a ordinary, what is the differentiation is nothing but if any function is derived with respect to at least neighborhood point. That is, we have the writing to the f of x minus f of a is less than is epsilon. Epsilon is greater than 0. So that neighborhood point is existing. That point will be the derivative of the function. That is, we can write into the limit h tends to a f of x minus f of
Sir, my voice not audible, sir.
x tends to a plus f of x is equal to limit x tends to a minus f of x. This condition is satisfied. That point a is neighborhood has a continuous function of the at the point of a. So that is a continuity of the function. Here the next the differentiation are the two types, the ordinary differentiation and partial differentiation. If any equation is a dependent and independent variable, the derivative with respect to only one independent variable. So that differentiation of equation is called as a ordinary differentiation. And partial differentiation. If any equation and dependent and independent variables is derivative, as involve the equation is derivative with respect to one or more independent variables, that is called as a partial differential equations. The ordinary differentiation we have the denoted by the capital D by dx, and partially differentiation we have the denoted by the small dou by dou x or dou t. We have the which independent variable have the writing to the writing to the same independent variables you can writing. Okay, so here in the partial differentiation of is the neighborhood of point of two variables. We have the writing to the one or more independent variables have the derivative. So here we have writing to the neighborhood point of a comma b. So a set of points within the circle. Within the circle, we can take into the one circle is radius is greater than 0. So entered at the point of a comma b is called as a neighborhood points. Neighborhood point of a comma b, the surrounded by the circle region, the circular region. So that is x minus a whole square plus y minus b whole square is less than or equal to r square. Is a one of the neighborhood point of the point. Next is a delta is a positive number in the set of a comma x comma y is a minus delta is less than x less than or equal to x is less than or equal to a plus delta, or b minus delta is less than or equal to y is less than or equal to b plus delta, which is a square bounded by the lines. That is x is equal to a minus x is equal to a minus delta, and x is equal to a plus delta, y is equal to sorry, y is equal to b minus lambda comma b plus lambda. Having to the centering the point of a comma b is called as a rectangular neighborhood. Rectangular neighborhood point of the a comma b. For different values of delta, we getting to the different neighborhood points of the a comma b. In other words, we can say into that, if you are taking to that, z is a function of three or more variables, like three or more means we have taking to the x, y, z is the three variables, or x, y, z into comma t also we have the another variable, four variables, like we can take into the x comma y comma z comma t. We have written the relation as the z is equal to f of x comma y comma z comma t. For this function, through the geometrical representation is not possible. We can existence of concept of region of neighborhood. ఇక్కడ మనకి డ్రా చేయడానికి, అంటే ఫిగర్స్ డ్రా చేయడానికి మనకి పాసిబిలిటీ కాదు, కాబట్టి వీ హ్యావ్ ద ఎగ్జిస్టింగ్ టు ద నైబర్హుడ్, నైబర్హుడ్ కాన్సెప్ట్ మనం యూజ్ చేసుకొని ప్రాబ్లమ్స్ సాల్వ్ చేస్తాం. ఓకే, వాట్ ఈస్ ద లిమిట్ ఆఫ్ ఫంక్షన్స్ ఆఫ్ టూ వేరియబుల్స్? Okay, we have the any function f of x comma y is said to be tends to limit x tends to, or x comma y is tends to a comma b, that is x tends to a and y tends to b. So according to the giving the positive numbers, that is delta, and there is existing the positive number of delta is such that f of x comma y is minus f l, so is less than delta for all positives, all the points of x comma y. Whenever the det of a minus mod of x minus a is less than or equal to delta, and mod of y minus b is less than or equal to delta. So this is called as a limit of the two variables. In other words, we can say into that the variable of values f of x comma y in the approaches to finite fixed value, the fixed value of limit L, which is corresponding to the their variables of values x comma y approaches in the fixed value a comma b, that is approaches a and y, x is approaches the a and y is approaches the b. So simultaneously we writing as this limit x tends to a, y tends to b, f of x comma y is equal to L. So maybe we can write into the limit of x comma y is tends to a comma b, f of x comma y is equal to L. So this is mean the corresponding to the to every positive number is epsilon that is existing to the neighborhood of the a comma b. This limit of every point x comma y of neighborhood f of x comma y lies between to the L minus epsilon and L plus epsilon. Another neighborhood is epsilon is a negligible positive value. So the limit of x comma y tends to a comma b, f of x comma y existing to the limit is an independent path along with the approaches to the a comma b. Okay, so this is we have the writing to that. And what is the continuity of functions in your two variables at a point? So we say that if any function f of x comma y, f of x comma y is a continuous in a point of a comma b, they corresponding to the any given positive number. If any given positive number epsilon, there existing the positive number is delta, and such that mod of f of x comma y is minus f of a comma b is less than delta whenever 0 is less than x minus a whole square plus y minus b whole square is less than delta square. So this is a continuous function. And in other words, we can say into f of x comma y is said to be continuous a comma b is a if domain of the definition of limit extends to a comma b, f of x comma y is equal to f of a comma b. If a function is continuous each point of domain, and then say that continuous in the domain. So the function which is not continuous is said to be, is not a discontinuity of the functions. Okay, once again we have the recalling to that what is the neighborhood point of x comma y and a comma b. So we have the writing to there. Here we can clear this board. If we have the saying to that neighborhood point of the if any circle, we can take into this the some radius, the small r. If any in a circle we have point of a comma b, if a point of a comma b, so in the surrounding of the circle is the neighborhood points. In these points all the values of neighborhood of the a comma b. That is, we have the writing to the circle is r is greater than 0 is extended to the a comma b, is a neighborhood point of the a comma b is surrounded with the surrounding to the circular region. So that is, we have the, you know that the circle form is writing to x minus a whole square plus y minus b whole square. Y minus b whole square is less than or equal to r square, is less than or equal to r square, and this is the neighborhood point of the circular region. So if you have positive number, if you have the positive number in the set of x comma y, if you have set of x comma y, you have any x and y axis. In x axis and y axis, we can take into the any circular any square or any rectangular points, we can take into this the positive numbers, and x comma y we have the taking to the in a x-axis, the a point is a minus delta and a plus delta. X is axis having to the a minus delta and a plus delta, and next y-axis to having to the a minus b minus delta, b minus delta comma b plus delta. So we can writing to the b plus delta, and this is which is the called as a comma b. A comma b is a rectangular neighborhoods of the point of a comma b. If any point of a comma b, we have the neighborhood points. So if you have the different values of delta, we can get into the different neighborhoods of the point of a comma b. In function and three or more variables we have to take into them, three or more axes we have to take into that. So a comma b comma c, or a comma b comma c comma d. So in this representation is difficulty. So we can take into the neighborhood points of a minus delta, a plus delta, and b plus b minus delta, b plus delta. We have to take into the every axis to neighborhood points of the values, is a negligible of the values. Neighborhood values is nothing but we have to take into the root 24, for example root 24. So you know that we have writing to the 16 root 16 value and root 25 value in between to the root 24 we can existing. So you know that is a 4 plus 4 or minus 4, and this is the plus 4 plus 5 or minus 5. So in this value root 24 also they're existing into the more than the 4 and less than the 6. So in neighborhood values is nothing but the plus or minus 4.786, like somebody we can write into the plus or minus 4.787. Somebody we can write in the plus or minus 4.798. So we have the neighborhood values, they have the negligible, they can write into the nearer to the square root values, the single variables. So if we have to take into the two variables we can write into there. We have the x comma y and y comma z. So in a plane, in the square and rectangular shapes, we can write into there. And limit of the function of two variables, we have the there is existing to the any function is a limit of point at the point of f of x comma y in the at the point of a comma b is tends to f of x comma y, f of x comma y is tends to x comma y is tends to L, or we can writing to as a value of, we have the writing to the x tends to a, and we have the point of a, the x tends to a comma b, we can write into the x tends to a and y tends to b. So in your single variable, we can know that they have any function f of x is tends to L, the limit of values of at the point of A. So we can write into the writing to x tends to A, and they have the representation of the then neighborhood values, and they say positive of values is there existing to the epsilon. We can write into the their existing to the neighborhood positive number is the delta. We can write into their satisfying to the value is f of det of mod of f of x comma y, f of x comma y minus L, is less than epsilon. Is the epsilon is the 0 is less than epsilon is less than delta. So in between to the neighborhood point of these two conditions are satisfied, that limit of the function is satisfying to the for the two variables. And if you have the representation of two variables of a neighborhood point in the circle, we can write into limit x tends to A and y tends to B, f of x comma y, f of x comma y is equal to L. Or somebody we have the writing to in this form, limit of x comma y is tends to A comma B is f of x comma y is equal to L. Limit of x comma y is tends to A comma B. So we have the, this is a representation of the values of limits. Okay, and continuity of the functions, they have the continuity of the functions. If f of x comma y is a continuous function at the point of A comma B, at the point of A comma B, and the corresponding any positive number is epsilon, any positive number is epsilon, and their existing to the positive number is delta. We can they satisfying to the mod of f of x comma y, f of x comma y is minus f of A comma B, f of A comma B is less than epsilon, and is less than the epsilon. And whenever the value of the 0 is less than or equal to x minus A whole square, plus y minus B whole square is less than or equal to or less than is delta square, is a delta square. There is existing to the these two conditions will be satisfied, that is a continuity function of the two variables. A function f of x comma y is said to be continuous in at the point of A comma B, the corresponding to any given positive number is epsilon. Their existing positive is delta. We can write into the mod of f of x comma y is minus f of A comma B is less than epsilon. So whenever is the writing to the 0 is less than, x minus A whole square is plus y minus B whole square is less than delta square. This is called as the continuity of the function of two variables. Okay, in other words, we can write into this saying to that f of x comma y is a continuous at the point of A comma B, and the domain of the near domain of definition of limit x tends to x comma y tends to A comma B, f of x comma y is equal to f of A comma B. This is in your domain to have there. So that is called as a continuous function. If you cannot have in your given point is domain, that is called as a discontinuity of the functions. Are you clear? If any doubts? Hello, ఏదో మాట్లాడినట్టు ఉంది కదా. హలో హలో చెప్పండి చెప్పండి నాన్న.
సార్ సమ్స్ ఎక్స్ప్లెయిన్ చేసేటప్పుడు ఇంకా బాగా అర్థమవుతుంది.
మ్యాథ్స్ సార్ థియరీ చెప్తే ఎలా ఉంటుంది అలా ఉందా? అంతేనా? ఓకే, సరే. Write the definitions for this. చిన్న డెఫినేషన్స్ ఉన్నాయి, రాసేసుకోండి. ఓకే, మనం రేపు ప్రాబ్లమ్స్ చేద్దాము వీటి మీద. రైట్ డౌన్. Partial differentiation, side heading. Partial differentiation. All of you write down partial differentiation. Neighborhood of point A comma B. Neighborhood of a point neighborhood of a point A comma B. Neighborhood of a point of A comma B. Okay, write down the first point. A set of points lying with a circle radius small r, that is greater than 0. Small r. Centered once again. Okay, a set of points lying lying within a circle radius small r, centered at A comma B, is called neighborhood of A comma B, surrounded by the circular region ఇక్కడ బాక్స్ కొట్టాను కూడా చూడండి నాన్న, ఆ బాక్స్ రాయండి. D is such that x minus a whole square plus y minus b whole square less than or equal to r square. Less than or equal to r square. Less than or equal to r square. Okay, second point. Let delta be a positive number. Delta be a positive number. The set x comma y such that a minus delta is less than or equal to x is less than or equal to a plus delta comma b minus delta is less than or equal to y is less than or equal to b plus delta. X comma y is such that a minus delta is less than or equal to x is less than or equal to a plus delta, b minus delta is less than or equal to y is less than or equal to b plus delta, which is square bounded by the lines square bounded by the lines x equal to a minus delta, x equal to a minus delta, x is equal to a minus delta, comma, x equal to a plus delta. Next, y equal to b minus delta, y is equal to b plus delta, having center at the point a comma b, is called a rectangular neighborhood, of the point, a rectangular neighborhood of the point a comma b, okay. Next, limit of a function of two variables. Next side heading, limit of a function of two variables. Okay. Okay, can I stop here?
Yes, sir.
Yes, sir.
Okay, tomorrow will be discuss this based on this continuity function, and this based on the some problems we have to doing tomorrow. Okay, problems చెప్తే మీకు కొంచెం అర్థమవుతుంది. Okay, okay, thank you.